All right, guys, I am the math professor, Kyle Martin, and today we're talking absolute value inequalities. All right, so with these three problems back here behind me, we're going to solve them, graph them, and write their interval notations using our steps that you see over here. All right, there are timestamps in the description below, so jump ahead to whichever problem you think will help you out the most. Let's get started. All right, before we jump into number one, let's look at our three steps. All right, our three steps to solve absolute value inequalities are: one, we need to isolate our absolute value bars, meaning that those should be the only thing on that side of the inequality. Everything else should be moved over to the other side. Once those and anything in them is isolated, then we can create our two cases, which is the next step. We're going to create a positive and a negative case, okay? And for absolute value inequalities, our negative case also has to switch the sign, okay? Lastly, our third step, we're going to solve both, graph both, and write the interval notation together, and you'll see it's going to form a compound inequality. All right, so let's try number one. Number one says -2 times the absolute value of x plus 3 is greater than 14. Okay, now with absolute value, you cannot distribute in like you can with parentheses. These are not parentheses. These are absolute value signs. So instead, what we have to do to get rid of this -2, we're going to have to divide by -2. Divide by -2. All right, and what that does for me is it cancels those on this side. We're left with the absolute value of x plus 3. And we divide it by a negative, so our sign switches. And then we get 14 divided by -2 is -7. But we run into an issue. And the issue is that absolute value implies distance. Distance is positive, okay? And it can't be negative. Or in this case, you can see the distance, which should be positive, is less than a negative. There's no way something positive can be less than something negative, so this one actually is no solution. No solution. All right, let's try number two. This one does have a solution. Number two says the absolute value of 2 plus 4x, all divided by 4, is greater than 5. Okay, so same idea. Our absolute value bars are not isolated. To get them isolated, I'm going to multiply both sides by 4. Multiply both sides by 4. 5 times 4 is going to be 20. But over here, first, the 4's are going to cancel. The absolute value of 2 plus 4x is greater than 20. Our sign stays the same, right? We multiply by a positive. Okay, now that my absolute value bars are isolated, I can create my two cases, my positive and negative case. I like to draw arrows to show my two cases. In the first case, the positive case, we're going to write it exactly like it looks, but we're going to drop our absolute value bars. So I have 2 plus 4x is greater than 20. In the negative case, we're going to do 2 plus 4x, but our sign has to switch, and our answer is now negative. So instead of greater than, I'm going to switch it to be less than, to 20, -20. Okay, go ahead and solve both. And we get x is greater than 18 divided by 4 is 4.5, 4.5. And over here, those cancel. X is less than -22 divided by 4 is -5.5. -5.5. Okay? So we solved them both. Now we need to graph and write their interval notation. And we do these together. Negative is always, -5.5 is to the left of 4.5. 4.5. Your teacher might need you to write out all those numbers in between. That's fine. I'm just going to do those two. It's a greater than and a less than, which are both open dots. And let's look at this one at a time. So x is greater than 4.5. So at 4.5, I need to go to the right. I need the numbers bigger than 4.5. And at -5.5, x is less than those. So the numbers to the left. All right, so this creates a compound inequality that's an OR compound inequality. It goes apart from each other. And then the interval notation for this, there's two pieces of the shading. So we're going to create two parts of our interval notation. We're going to do negative infinity to -5.5. Negative infinities and positive infinities always get parentheses, so do open dots. And then 4.5 to positive infinity. Again, both with parentheses there. And then some teachers do require that you put a union symbol in between those to show that both pieces satisfy the inequality. All right, number 3. Number 3, negative 4 times the absolute value of negative 8 plus 1, and then outside the absolute value plus 5 is greater than or equal to negative 55. All right, so first off, we're going to have to get our absolute value bars isolated by subtracting 5. Negative 4 times the absolute value of negative 8x plus 1. Those cancel. It's greater than or equal to negative 55 minus 5 is negative 60. Okay, right now at the back this is negative, but when I divide by this negative 4, that should help. And it does. The negative 4s are going to cancel. The absolute value of negative 8x plus 1. And then my sign, since I divided by a negative, is going to switch. So instead of greater than, it's now going to be less than or equal to. And then negative and divided by negative is a positive. 60 divided by 4 is 15. Okay, now that it's isolated, my absolute value bars are isolated, I can create my two cases, a positive and a negative case. For the positive case, drop the bars, write it exactly like it looks. Negative 8x plus 1 is less than or equal to 15. For the negative case, negative 8x plus 1, but then switch your sign and make your answer negative. Divided by negative 8. Our sign is actually going to switch one more time because we divided by a negative again. So here we're going to be left with x is greater than or equal to 14 divided by a negative 8 is 7/4, negative 7/4. And over here, x is, again, switch your sign because you divided by a negative, less than or equal to negative 16 divided by negative 8 is 2. Okay, so negative 7/4 when we graph this is left of our 2. Negative 7/4. 2 is over here. Both of them are going to have closed dots. Closed dots, and then just take it one at a time. X is greater than or equal to negative 7/4, so we're shading to the right. And x is less than or equal to 2, so we're shading back to the left. Now this only has one piece of shading, so our answer is just gonna, our interval notation I should say, is just gonna have one part to it, from negative 7/4 to 2, negative 7/4 going to 2. Both of them are closed dots, so they both get brackets. Both of those will have brackets around them. All right, guys, I am the math professor, Kyle Martin. If these problems up here helped you out at all, please do me a favor and help me out by subscribing to this channel. Okay, you already came here once for math help. You know you're going to have to come back. So hit that subscribe button.